Hi everybody, welcome to this webinar from Variscite and NXP. My name is Pierluigi Pastro. I'm part of the R&D software team. Today with me there's James Pryor, product manager at Advanced Processor Innovation team in NXP. Today we will provide you details about the new system on chip provided by NXP, the i.MX 95. This is the agenda. We will talk briefly about Variscite. NXP will introduce the i.MX 95 application team. We will talk about Variscite pin-to-pin families. Then we will go deeply in the Dart MX6 95 SOM, its carrier, the software support. We will talk about Variscite customer support. We will have some time for questions and answers, and we will provide some useful link at the end of this webinar. Let's start talking about Variscite. Variscite is in this market since 20 years ago. We are in some market with an extensive customer base and pipeline. We have a stable supply using our internal production facilities. So we have full control of our production, even in terms of customization and delivery and what else. We provide direct support from the R&D team within 24 hours for the customer portal to all our customers. NXP, Variscite is an NXP Platinum partner since years nowadays. We provided the most diversified i.MX-based portfolio in terms of SOMs. We have a very high quality standard meeting the strictest regulatory requirement, including those for our several medical customers. And we rely on an ecosystem of partners for a complete end-to-end solution from the hardware design to the software projects. Which is the advantage of using Variscite? First of all, we provide two pin-to-pin product families, enabling the quick migration to future technologies. We will go deeply later in these pin-to-pin families, but basically sharing the same carrier. We provided different SOM, and just switching the SOM from one to the other, you can achieve a completely different product in terms of power, features, and functionalities. There is a full SOM customization capability, 100% yield all the time. All our hardware is production ready, including the software itself. Our SOM are tested by thousands of customers worldwide, proven high quality and low risk using our SOM. We provide free customer support through the customer portal, GitHub, the wiki, and also through CAD for hardware design. And all our SOM rely on a very robust longevity, up to 15 years for hardware and software. Now let's have James introducing the i.MX 95.
Hi everybody, this is James Pryor with NXP. Thank you so much to Variscite for inviting me to be part of this discussion with your customers about the upcoming i.MX 95 series of application processors. We built the i.MX 95 for addressing a very broad range of markets, and we have a number of brand new first for NXP features and IP inside of this technology, which we're excited to talk and share to you about. The NXP i.MX 95 family of application processors will for the first time include a safety capable platform. So we'll be able to ditch the hypervisor and have simply safety capable platforms with our first generation of on-die i.MX functional safety frameworks. So this includes the NXP Safety Manager, safety documentation, and NXP professional support to enable ASIL-B or SIL2 computing platforms, not just a safety island with an integrated microcontroller, but also with a safe 2D display pipeline. So for those critical HMI applications where displaying or knowing that the graphics display is going to work is critical, then we enable that functionality with the i.MX 95. We're also introducing the first time our NXP developed EIQ Neutron NPU, Neural Processing Unit, an AI accelerator for the edge. It'll allow you to accelerate many different AI ML workloads, including some preliminary generative AI style workloads to give an enhanced command and control for voice applications, for time series situations. We'll go into more details on the AI ML accelerator in further slides as well. We're also including PCIe Gen 3 lanes, 10 gig Ethernet, and USB 3 5 gigabit per second ports to connect more and more devices with the i.MX 95 and do that securely with the integrated on-die edge-lock secure enclave and VTech accelerator, including post-quantum cryptography capabilities, so you can securely boot, run many different applications and connect different sensors or other sources of data to the i.MX 95. Finally, we're also including the ARM Mali graphics for the first time in an i.MX application processor. So powerful, high performance, beautiful, immersive 3D graphics are going to be part of the capabilities that lets you build very, very capable displays and high performance graphics using the power of the Android and Linux ecosystems as enabled by ARM. So next slide, please, Pierre. Thank you. Let's talk a little bit about the Energy Flex architecture and how we've designed this processor differently from, say, a commercial consumer SoC. So we have multiple power domains that enable fine gain control for low power operating modes. We can go down to as low as 5 milliwatt with just the ARM Cortex M33 in a low power state, waiting for something to happen and be triggered either by a microphone or an Ethernet port or a CAN port or some other low power interface. The 6 A55 cores offer individual power and performance control. We have individual clock frequencies, so you can adjust that through your software or allow Linux to manage it however you choose. You also have a powerful ARM Cortex M7 for real-time embedded applications, and that all of these different cores have different access to the hardware, and you can hardware isolate them so you can safely pass messages from Ethernet through the M7 to the Linux domain or vice versa for high performance secure processing and responsiveness. Next slide, please. So I talked a little bit about the brand new EIQ Neutron NPU. This is internally developed by NXP for AI ML acceleration, really focused on edge AI workloads. This is for inference processing. So we're not talking about learning, we're not talking about data centers, we're talking about at the edge, running those major neural net structures you're familiar with, like CNN, RNN, MLP, etc., trying to get the highest possible efficiency out of that. So we classify this as a 2 TOPS neural processing unit, which if you're familiar with the i.MX 8M+, you might think, hey, that's lower power, that's lower performance than the 8M+. What you'll see here is up to 3 times the performance of the 8M+ through increased efficiency. TOPS is a very simple mechanical measure of performance, frequency times bit width, and the actual performance is only really shown up in the applications, in the workloads itself. So we're enabling a ton of different workloads. You can see here in our chart how the performance scales to different objects. So you can see that the under 128 GOPS to 512 GOPS, it can be powered by a CPU or a GPU. As you get into live video, face, and object recognition, we need a large dictionary, multi-speaker speech support, or live video upscaling and denoising. You need more performance efficiently delivered at the edge, on die, and integrated. And that's really where the EIQ Neutron is targeted for. Next slide, please. So how do you leverage the EIQ Neutron? Well, it's pretty simple. We have the EIQ software development environment, which scales across all of our i.MX application processors and even our microcontrollers as well, to help you simply and easily take your data or your model and move it to an NXP i.MX application processor. We have a command line or graphical interface. The graphical interface is new, provide our own models and pipelines for audio and voice, vision or time series, etc. And we have an application code hub where you can download these to use with your data. If you have your own model already, you can push that through our converter for TensorFlow, PyTorch, or i.MX support and target the different parts of your application process that you want to use. And we're also the first, NXP is the first semiconductor company to announce native NVIDIA Tau toolkit API integration. As we know, 90% of the deep learning models are trained on NVIDIA hardware, and this makes it simpler and easier than ever to take that model, push it onto your device, and use it with your data as simply and as easily as possible. And this will scale across i.MX 8M+, i.MX 93, and i.MX 95. It doesn't matter which IP is inside, we can support it. Next slide, please. Let's talk a little bit more about the secure enclave. We first saw the edgelock secure enclave and the i.MX 8M, excuse me, 8 ULP and the i.MX 93. We're taking it to the next level with the i.MX 95. So that same silicon root of trust and runtime certificate attestation and simplified path to certifications is included inside the silicon. We're adding key management and device-wide security intelligence, as well as trust provisioning. So you have a wide range of security services, not just for protecting applications, but also for physical security. So you can monitor those secure elements, the different parts of the chip as well. We're going to add on to this with a V2X accelerator. So bulk cryptography for those different workloads that require communication between multiple different devices, communicating, telling them, letting them know what's going on, suitable for multiple applications from robotics or autonomous communication through to data streams from multiple sensors coming from multiple sources. This is how we enable secure boot. It's how we can enable cloud management throughout the life cycle of a product. You don't have to use NXP's provided lifecycle management either. You can build your own factory for remotely managing the device, and this is all unlocked for you in part of the i.MX 95. Next slide, please. So in summary, the i.MX 95 is a secure connected edge application processor with a huge range of applications, with a lot of new IP, a lot of new features, really enabling partners like Variscite who can take their expertise and demonstrated excellence in these different markets and focus on your applications. We're proud to partner with Variscite and help them bring to market the i.MX 95 series of carrier boards and solutions with all this new IP. We're in our early access program now. We're proud that Variscite are part of that early access, getting a head start on the design ahead of the market entry in second half of 2025. And we'll be enabling many of our partners this year hands-on with the evaluation kits. And we hope that you will consider working with Variscite for your i.MX 95 design. Thank you.
Thank you, James. Going on, now we can talk about the pin-to-pin families. Variscite provides two different pin-to-pin families. The first one is the VarSOM. The VarSOM include some starting from the 6UL up to the 93, 91, all the 8 families, going through also the MXCs. These families is featuring a SUDIM connector, which exposes, of course, several pins from the SoC or from the component, and the carrier board is designed to be compatible through all of these SOMs. So you can use the same Symphony board and scale from the 6UL up to the 8M Mini rather than the 8M or the 8 Code Max, whatever you like. Of course, you need different software, but you can keep using the same reference board for all of them. Now let's focusing on 95. We choose the Dart form factor for the 95 because it exposes some more pins, and this is reasonable due to the additional feature of the 95. And in this family, we started with the 8M. When we had the Mini, the Plus, Recently, we added the 91, the 93, and now the 95. So again, all these SOMs share the same carrier board, the DT8M custom board, where we have chosen specifically configuration that can be compatible between all the SOMs. And that's why the board can be reused as it is. And our DSP is designed to reuse this feature as much as possible. Let's compare now the families belonging to the SOM belonging to the Dart families. We started with the i.MX, I said. It was a 4 Cortex A53. The same was for the Mini and for the Plus. For the Dart 91, we started with Cortex A55, 1 core, 93, 2 cores, and the 96 up to 6 cores. Real-time side, all of these, almost all of these SoCs features a Cortex-M. It was a Cortex M4 for 8M and 8M Mini. 91 doesn't feature a Cortex-M, but the 93 has a Cortex-M33, and the 95 has both the Cortex-M7 and the Cortex-M33. As you can see, also the speeds increase along the path. GPU side, we can see something similar. So the Vivante for the 8M families in some declination, I would say, for the M Mini and M Plus. The 91 has no specific acceleration. It's just a frame buffer SoC. The 93 features the pixel pipeline, that is a 2D accelerator, while the 95 can provide 2D and 3D acceleration through the Mali G10. GPU side, in MPU side, sorry, the Plus was the first one introducing an MPU. It was the Vivante VIP 9000. Then the 93 introduced the Ethos, and as James already said, the 95 introduced the Neutron. Also, RAM size, we can see some differences. We started with 4 gigabytes, then we raised it up to 8 gigabytes for the 8M Plus. And now with the 95, we can reach 16 gigabytes of LPDDR4. Display side, while the Mini the 91 and the 93 support one display, the 8M support 2 displays choosing between LVDS, DSI, and HDMI. The 8M Plus support 3 interfaces, and the i.MX 95 support up to 4 displays. Which is the advantage of choosing a pin-to-pin family? First of all, the scalability. Once you have your card designed, you can just scale up or down some and provide different products with the same hardware. So there's no need to redesign while scaling. You can just reuse your carrier board as it is. The point is that you must design the board thinking to the scalability. This also allows the customer to optimize the cost and the performance of the product. In case you have different product, you can consider optimizing for different product, different SOM. You can easily develop and integrate your hardware. Variscite will be in charge for providing the reference DSP, so you will be able to start from a very good base. And NXP provide a very interesting lifetime for all this product. We just extended the same lifetime. So whenever NXP extended the lifetime, we also extended the lifetime. There are SOMs that were provided with 15 years of longevity, but nowadays we know that the longevity is much more higher than 15 years. Let's talk about the SOM. Here you can see the SOM. As I said, it's able to provide up to 6 Cortex A55, 1 Cortex M7, and 1 Cortex M33 to do 3D acceleration through the Mali. Dual display 24-bit Full HD, but also MIPI DSi 4K, hardware encoding and decoding video for H.264 and H.265, 2 MIPI cameras, plus image sensor processing, AI and machine learning NPU, the Neutron, USB 3, USB 2, 2 gigabit Ethernet, but also 1 10 gigabit Ethernet, plus 2 PCI interfaces. On top of the model, we provide a Wi-Fi 6 chip that is able to also feature the 802.15.4 standard with Bluetooth support up to 5.3 standard. The RAM is available up to 16 gigabytes of LPDDR with up to 128 gigabytes of eMMC. The extended range is available, the industrial range is available from -40 to 85. For more detail, you can check the web page. And this is the SOM. You can identify the processor, the LPDDR5, the PMIC, the gigabit LAN. The eMMC is on the back. You can see it here on the back. And the Wi-Fi module from Murata, which is actually mounting an XP chip. This is the configurations available for this SOM. So for sure, the 6 cores, you can choose between 2000 megahertz or 1.8 gigahertz. You can choose the LPDDR5 size for 8 or 16 gigabytes. You can choose the eMMC size. You can choose to mount or not the audio codec, the gigabit Ethernet fee on the SOM, the Bluetooth Wi-Fi, and you can choose between the version with and the one without 802.15.4 interface. We provide a DSCM version which is compatible to provide the dual VDS on a specific position plus the DSI. And this is useful whenever you need to achieve a compatibility with older SOM. We can expose or not the ADC lines. There is a compatibility option, another compatibility option to avoiding connecting a few pins that may provide differences, and then you can choose the extension grade. This is the block diagram of the i.MX 95 SOM. The Dart basically includes the SoC plus some peripheral immediately on the SOM, like the DDR, the eMMC, some crystal, some EEPROM, and so on. And then there is the PMIC, and there are also some optional mounting options like the Ethernet fee, the audio codec. As you can see, the block diagram shows that you can remove the Ethernet fee and have a kind of shortcut that basically expose the pins not used directly at the SOM connector. The same applies to the audio codec and to the Wi-Fi Bluetooth chip. So whenever the customer starts designing the carrier, thinking about scalability, they always need to check the pins that they are going to choose in order to keep the compatibility among several SOMs. And what we provide already does this. So it's a reference implementation that can be used as it is. Now let's start talking about the carrier. Basically, this is the Dart MX8 MX95 carrier. It's called DT8M custom board because the Dart MX8M was the very first SOM using this carrier. You can see on the top the free IROS connector that provided the interface to all the pins. And basically, this carrier comes with its own BSP and already available with all the features of the SOM. So the Wi-Fi, the Bluetooth, the display, the Ethernet are working, the USB is working, whatever. For more detail, you can always check the website where you can find all the details about this carrier and the schematics. When you download the schematic, you will find the pinout of the main free IROS connector. And this will match the data sheet of the SOM for all the pins that you may want to connect. We also provide a compatibility spreadsheet so that the customer can choose which functionality you want to maintain in the compatibility. We provide the schematics of the carrier. We provide the design and layout guidelines. And we also provide free schematic review for all the customers that may require it. Let's switch to the software support. For what software side, we provide the developer guide in the wiki with general info, the build instruction, and the auto section. And in the release notes, we directly provide the shortcut to the repositories and to the recovery image. For the time being, you will check, if you check to the wiki page, it's still coming soon. We are currently working on the release. We are again in a very good shape for the time being. So we expect to release shortly, initially the Yocto DSP, and then we will move to the Debian. What will happen is something like this. You will see from the wiki page, like a tab like the one on the left. You can click on the developer guide and you will see 3 columns. The 3 columns, the general, the build, and the how-to, basically can guide the customer through all the steps. So you can find out to set up the build machine. You can start the build in Yocto from source code, just following step by step what we provide. There will be the specific instruction to build the U-boot from source code as well as the kernel. We will provide the instruction for the software update that is a framework to remotely update all the DSP remotely on the target. And also we provide details about the Docker support, which is nowadays very, very used. In the how-to section, you will find a quick way to immediately test all the features just using the recovery image. The recovery image can be downloaded from the release notes. You will find the link. Just you download the binary, you burn it on the SD card, and you will get the same result as building Yocto from source code. It will just save you time. But in the same time, you will be allowed to test the features of the SOM to check if everything is compatible with your requirement. As I said, the first one will be Yocto unbuild. Almost immediately will follow Debian Bookworm, that is a derivation of Yocto unbuild, where we will provide Debian packages support for all the users that may require, let's say, a quick access to the packages without building through Yocto. You will find in our website the links to the public software. Everything is managed through GitHub. We are fully aligned with the NXP BSP. Before releasing, we need to go through an automated test for validating the BSP. This nowadays is one of the biggest activity that we have internally to automate all these tests. But whenever in the future, for any reason, any patch will come from Variscite or from NXP and will be required for any of the BSP that we are maintaining, these patches will be automatically, not automatically, but will be pushed by the software team directly to the repositories. And this applies, for example, to software enhancement that may arise along by the customer, rather than hardware changes. You maybe change. It happened in the past that we had to change some component because reaching their end of life. R&D side, instead, we work on GitHub in the backend using CI/CD, so continuous integration and development. This is improving the developer experience, also increasing the quality of the software. For sake of knowledge, these are the basic information for the BSP that will be released shortly. We recommend using U-Boot 2004 or 2204. The ATF in U-Boot and Linux kernel will come from the NXP release. We will have a dedicated Variscite layer, actually more than one layer, that will be based on original NXP layer. The GCC version will be 13.2. The Qt version will be 6.5.3. Chromium will be raised up to 1.17. And for Debian, we will use Bookworm 12.5. Now we can talk about the Variscite customer support. The first entry point is always the website. So on the website, you will find at the bottom of the page of the SOM these 6 boxes with the reference manuals, the carrier board schematics and datasheet, the mechanical files, the operating system support, the Linux distribution, and all the certification that will come with them. So this is in the website, immediately accessible without any login or other. This material is completely public. Beside this, we have dedicated Python documentation, also in this case completely public, that try to satisfy the increasing request from the customer of having a Python API to access the NXP world, the Cortex-M, the GPU, the CPU capability, the NPU, the multimedia, but also other examples. You can just reach out to this website and check whatever is available and use it free of charge. For the customer that need dedicated support, in the past we were using the forum. We decided to move to a portal, to a closed portal, just because some customers were reporting that we were uncomfortable to share, let's say, confidential data publicly. So this saved the customer from sharing unwanted data. The customer support here is based on an access, login and password. It's free of charge. You just need to register. The structure is based on a company, so all the members of the same company can access the same tickets and share the information between each other. On the other side, we provide the general SOM info. We suggest we provide the info about the carrier design, and we provide schematics. Software side, more or less the same. We provide the general software info. We provide general guidelines for the display customization, and we provide device tree reviews in case of problems. On the bottom of the page, you can find the link to the page where to log in. The team is spread worldwide. Basically, we have local support in Europe, Middle East, North America, and South America. This allows Variscite to be quite responsive. Usually within 24 hours, we are in touch with the customer. In case of demand, the team can be also reach the customer on site. And now, question and answer time. So feel free to ask. Let's see. Okay. We have a question about the GPU driver support. If it will be an upstream support or open source support. James, do you have any specific information about this?
Yeah, you kind of broke up asking the question. Can you repeat it for me, please?
One of the customers is asking if the GPU driver will be using the upstream support for Mali, if it will be an open source support or will be a closed support.
Yeah, it'll be the standard ARM Mali driver release. So yeah, it'll be upstreamed part of the kernel. We expect this ARM Mali G310 V2 IP to be widely used in the semiconductor industry. It's not just going to be used by NXP. Although we are one of the first to tape it out, you're going to see it in a lot of different devices for IoT and consumer and commercial platforms. So you're going to see a lot of different vendors supporting it. There was a lot of discussion about this IP at the Game Developers Conference in Canada this year. And it's going to be targeted by a lot of different graphical UI developers and other so third-party commercial supported developers. So they're going to need that driver. So you're going to get the benefit of the ARM ecosystem, the open source support that you see from ARM Mali today and other ARM graphics.
Okay. So there is a question about the presentation itself. This presentation will be available online on Variscite website shortly, and will be also reachable through the YouTube channel of Variscite. We have another question about PSA Level 3 certification for i.MX 9 series. James, do you have any specific info about this?
Yeah, that's a great question. So it's definitely a target for the i.MX 95. We're going through the final stages, completing it for i.MX 93 right now. Obviously we need the final silicon in mass production to complete that. So we're aiming for that milestone in the middle of 2025 for the i.MX 95, which will enable us to deliver those certifications toward the end of 2025 is the current plan of record. Maybe things change. So don't hold me to that specific date, but that's where we're targeting.
Okay. Another customer is asking about if there will be available an automotive version of the SoC ranging -40 to 125.
Yeah, that's a great question. So yes, we'll have multiple packages and multiple temperature qualifications. So the primary package that we're introducing right now is the 19 by 19 with 0.7 millimeter pin pitch. It'll be available in automotive qualification AEC Q100 with -40 T ambient to 125 C T junction. Temperature range. We'll also have the extended industrial, similar temperature range, and industrial ranges as well as commercial. That's all part of our 15-year longevity program from NXP. So once we launch, we expect to produce and supply this processor for a minimum of 15 years for those different packages and life and temperature qualifications.
Okay. There's a customer that is asking when the board will be available. I can answer this. Basically, you can contact our sales. We have customers that are already requesting the evaluation kit, so just contact our sales. What else? Another customer asking about the open source, already answered. The one is customer is asking if there will be LVDS parallel Support, yes, it will be. There will be up to interface LVDS on this system on chip. Then will be available also for the SOM. Let's say, okay, for whoever is asking information about buying this SOM, please reach out to Variscite Sales from the contact us web page. And there's a customer asking, James, this is for you probably, which other member of the family are planning in terms of course features, if there will be, let's say, depopulated SoCs in the i.MX, then the i.MX 95.
Yeah, that's a great question. So we do refer to the i.MX 95 as a family of application processors, and you quite correctly assume that that means there will be different parts that will have different features enablement. So currently all we're talking about and showing off is what we call the superset with all the IP cores and features enabled. We will have additional variants that will have different amount of cores and other IPs enabled or disabled based on the market focus, whether that's for purely vision applications or purely HMI graphic applications, or just powerful compute with networking and expansion capabilities and i.MX acceleration and safety. Those will all be available. We'll publish more details of them and the range publicly later this year. But otherwise, you can reach out in private to Variscite, and we can give them the information to help you understand the range and depth of the portfolio.
There's a customer asking if everything will be open source. As long as possible, everything will be open source and will be reachable through our GitHub repositories. So you will just have to follow the instruction in the wiki to build your own image. About the drivers for the ISP and the NPU. For the NPU, we will have a dedicated framework, as in the past, provided by NXP, and the same is for the ISP. NXP will provide a dedicated driver. And another question, the DRAM is on the board or external? It will be directly on the SOM. So you will just have to choose the size of the DDR you want, and you will get it on the SOM directly. Then we have a few other questions. Let me check. Oh, another customer is asking about quantities for the customization. Please contact the sales. Usually we can reach an agreement quite easily about the MOQ. So just contact the sale and we'll get all the information you may need. Okay. Let's see if there is anything else. Customer is asking about HDMI interface. James, correct me if I'm wrong, there's no HDMI native interface on the silicon, correct?
Yeah, that's right. We have a native MIPI DSI, and we have two LVDS, but no natively integrated HDMI.
Okay, let me add that we have customers that designed their own carrier, starting from the MIPI DSI with bridges. Whenever the HDMI is a mandatory feature, there are dedicated bridges both for MIPI DSI or LVDS that can allow adding the HDMI feature. Okay. Okay. Time is it? I think for the time being, we can close with the questions. Just a quick overview of the useful links. You can reach Variscite through the website, sales email, the contact support, the wiki, and GitHub. So thanks, James. Thanks to all of you for following us, and we will see you to the next webinar.